Now we're going to solve a phase change diagram problem. To do this, you're going to always start out with a graph, and it goes up and over and up and over and up. Each one of these slanted areas represents a state of matter. Each one of these flat plateaus represents the change in a state of matter. This problem is problem 1 from our worksheet, given 80 grams of ethanol. Find the energy for each phase and what's the total energy input if you're going from a negative 114 to 100 degrees. This first sloped area on the graph is where that represents the increase in temperature, temperature's over here, increase in temperature of a solid. This is where we increase the temperature of a liquid. Here's where we increase the temperature of a gas. These flat plateaus represent the time that it is taking for the substance, in this case ethanol, to either freeze or melt and then either condense or boil. Of course, that word depends on whether or not I'm going up the graph. In that case, it would be melting and boiling, or if I was coming down, it would be condensing and freezing. And that's whether or not I'm taking away heat temperature or increasing it. Lots of reasons why that thing is a flat plateau, and one of it is that it takes a lot of time for that transaction to occur because the solid only vibrates, but a liquid vibrates and rotates. That's the kind of motion those particles have, and it takes a little bit of time to acquire those changes in their motion. Up here, this vibrates and rotates, but this vibrates, rotates, and translates. So once again, a flat plateau allowing for the time for that to happen. We've got to set up our graph. So this first plateau, as we said, was the melting point. So the melting point of ethanol is negative 114. So out to the side of the graph, I set up my negative 114 right there. And boiling point is 78 degrees. So out to the side of the graph at the next plateau, I set up my 78 degrees. Now I know where each of the temperature changes are going to be at. I can do the math required for the problem. The equation for the problem told me to go from, there's a typo. This should say a negative 130 up to 100 degrees. So we're going to do it not as this, but as a negative 130. So the equation is energy equals mc delta T, where the M stands for the mass. The C is the specific heat, and the delta T stands for the change in temperature. So that is the same equation, except you'll notice there is no change in temperature. So instead of calling it specific heat also, it's the heat of fusion. So energy equals mass times the heat of fusion number. For this one, it's the identical equation as down here, mc delta T. Here, instead of heat of fusion, of course, it's not melting or freezing, it's boiling, so that's called the heat of vapor. And up here, we're going to be using the same equation, mc delta T. So when we plug in our numbers, the first thing is I have mass, that's going to be 80. The specific heat of a solid, the specific heat of a solid is 0.232. And the change in temperature, if I'm going from the amended negative 130 to 114, that's 16 degrees. So when I set up my problem, it will be 80 times 0.32 times the 16 degrees. For this portion of the transaction, it's 296.96 calories. The next piece is mass, which once again is 80, and the heat of fusion number is 25, so that's 2,000 calories. This next piece of the problem, the mass is still 80. The specific heat, but now I'm a liquid. The specific heat of a liquid ethanol is 0.581. And the change in temperature between negative 114 and 78. Remember, there's a 0 in between there, so that's 114 plus 78, so that's 192. And so my number is 8,924.16 calories. Up here, we've got the mass still of 80. The heat of vaporization is 204. And so my number is 16,320 calories. And up here, I've still got 80. I've got the specific heat of a gas is 0.406. And I'm going from 78 to 100. So that's 22. So 80 times 0.406 times 22 is 714. The problem also asked me to find the total energy input, and that's just a matter of totaling up the information here, 714, 1630, 16,320, 8,924.16, 2,000, and 296.96. When I add those all up, I get 28,255.68 calories. So that's how you solve the problem. If this problem were different and I was only going through a portion of the phase, like say I was only starting here and going to here, then I wouldn't have these phases and you wouldn't include them in. So please read the problem carefully. This problem should have said going from negative 130 to 100 degrees.